There is a system variable called path. And double-click this variable. At the end of this variable value, add this directory, add this folder to it, d/transims. In this way, no matter where your current folder is, you will always be able to locate these transims program files. Are we clear about this? So you unzip your files into d/transims, and you add this d/transims to the last of this variable called a path, system variable called a path. This one. Just add these things here. To validate if you have already successfully added, you go to run cmd command, cmd, and you just type anything in transims, for example, gsnap. And it shows you that the gsnap has already been executed. So we are fine. Okay, after installing transims, the next step I want to do is to create a network or a four-way stop signs. So here is a shapefile of the Erie County. I think I showed you in the GIS lecture. This is a shapefile of GIS of Erie County, and I want to use part of it to create a demo network. So I just zoom in. For example, we use this button to select features, select some of them, and then I can right-click and export the data to a new shapefile. Okay? By doing this, we can create a sub-network, sub-area network. After creating the shapefile, for example, I created the shapefile here. Called cross, and let me load it so you can see what it is. GIS. I will be able to select the layer I created. Okay, so this is a sub-area, which is a very simple place I want to model today. This is shapefile. This is where we begin. In order to show you transims, how we can use transims, I developed a new set of files that you can use, which is completely different from what you have seen, what you can find online. So this is my work. And here is the folder of transims _Shan, which means the work. This is folder I will be uploading today. So you see numbers 0, 1, 2, 3, 4, 5. The number at the beginning of the folder indicates the sequence. The sequence of tools that you want to execute. And we start with tool 1, not tool 0, tool 1 called gsnap. gsnap is for converting the shapefile I just cut it into generic network files. And if you enter this folder, you will see one folder called input, the other one called output. And here, and two files, one called gsnap.bat, which is a batch file. In the batch file, there is only one line to execute the gsnap.exe, the transim tool, to do something according to the keys in gsnap.ctl. And this -p means you will pause after finishing it. Okay, so everything is defined in gsnap.control.ctl, and you open it. Here, this file was created by me yesterday. So this is, for example, this is a key, this is the value, this is another key, this is the value. So these are parameters name and parameters values. Okay, there are three keys required in gsnap. GSLink file, which is the cross.shp I just created, and you want to specify two tables. One is called a node table, The other one is called a link table. And here are some optional keys. This character means commenting. So each line, every line starts with this character. What's that, pound? What's this character called, Andrew? Pound. Yeah, pound. Okay. So each line starts with pound. Is only for commenting. They are comments. So you can see a lot of optional keys, but they are not used. We just use these lines, these keys that are without this pound character. And here it specifies the input file, and it specifies 3 output files, and they are all in CSV format, which is comma delimited format. You will be able to see it. And here you will be able to specify the input coordinate system, which I introduced in GIS lecture, which is UTM 18N in meters, and the output coordinate system. So that's very simple, right? Specify these things. And if you run it, let's check. In input, we have the shapefile in the directory of input. And in the directory of output, we have a lot, some files. Let me delete them. These are the outputs. So let me double click GSNet, and it's finished. So it says it reads the link file from GIS, which has 7 records, and it's writing 3 new files, and the process is completed. Press enter to continue. Then it's done. Then we check the output folder. We see 6 files. Actually, 3 pairs of files. Let me zoom in. So here is a file called input node. If we double click it, we can open it with Excel. This file just shows you there are 8 nodes created. And for each node, it has X coordinate, Y coordinate, and Z coordinate. Easy to understand, right? So we created 8 nodes using the tool called GSNet. Here's another file called input_node.csv.def. This file is the metadata of the CSV file. It's sometimes very useful. If we edit, you will see this is description of the CS file we created. And by using this DEF file, transients will be able to read it without any mistake. So keep it with the CSV. Okay, so 2 files. We just saw the node file, then we check the link file. In this link file, we see 7 links. And each link is from one node to another node, which is A node and B node. And each link has its length and a lot of parameters. See, a lot of parameters, and they are all by default zeros. And here is a file called input shape, and it defines the intermediate nodes that are used for each link. So it's like the curve. It's like a file to represent the curves. Okay. And I just open them using Excel. I can also open them using Notepad++. And I recommend you to try this. So now you see how the CS files are written. Each record is, all the records are separated by commas. That's so simple. And you can use it by Excel. Okay? So now we can see this file called input link. In order to go to the next step, we have to supplement some basic attributes. For example, the type of the link. Let me just write local here. Local is one option. But in order to set that, I just say local. So each road is a local type. And here is length AB, which means the number of lanes from A to B. So I just use 2. For example, say 2. And just paste it here. This left AB is the number of left-turn parking lane. This is right-turn parking lane. And the speed AB means the speed limit from A to B. And the unit is meter per second. So what is meter per second? Let's check about 40 miles per hour. 40 miles per hour will be equal to 40 multiplied by 1609 kilometers per hour and divided by 3.6. So it's equal to almost 18 meters per second. Okay? Then I just paste it here. Length AB. For free flow speed, I just use the same thing. Length BA, let me all write down 2. And speed BA, free speed BA. And the last one is called use. So this means the restriction. So which vehicles can use this link? So I just write down any, capitalize any. And by doing this, I have created some generic network files that can be further processed. So I save it. And if we check it, not this one. We are going to see all the attributes filled. Okay, so this is first step. The next step is called transims net. The output of transims net will be the network that is ready for transims. And the input of transims net is the files I just created. So we go into transims net. We copy these 6 files, 3 pairs of files, into the input folder of transims net. So I just delete them and paste them here. Okay, 6 files. And if we check this transimsnet.ctl, we see more keys here. So we have input/inputnode.csv, input/inputlink.inputnode and inputlink.csv. So these are the input files I just created, and it's going to create a lot of new files in the folder of output. Are they easy to understand? And here is a parameter called the maximum